Next up is talking about synthetic division. Now, synthetic division is a process that you can use to divide a polynomial by a linear factor. What do I mean by a linear factor? A linear factor of the form x minus a. Okay? If you have a linear factor of this form x minus a, then we can use synthetic division. Now, synthetic division is just easier. Okay? It reduces the amount of writing you have to do. It's basically the same process, but it reduces the amount of writing you can do, and you can make the process much, much quicker. So let's take a look at synthetic division on this first one. I've got 2x cubed minus 7x squared plus 5 divided by x minus 3. Okay? Now, the process of synthetic division takes a little bit, but it's not that bad once you get used to it. The first thing that you want to do is realize what your numerator here has in terms of all the coefficients of each of the individual terms in this polynomial. So what's the first coefficient? Well, the first coefficient is 2. That's my x cubed term. The next coefficient is negative 7. That's my x squared term. Now the next term down is actually a missing term, right? It's the 0x that's missing. So I'm going to put a 0 here. And then the constant term, the degree 0 term, has a coefficient of 5. Okay? So 2 for the x cubed, negative 7 for the x squared, 0 for the missing degree 1 term in here, and 5 for the constant term. This is very important to put in. You must put this in. Now, this has the form x minus 3. So if we ever have a factor of the form x minus a number, that number here, x minus, what number are we subtracting? 3. 3, I'm going to put this guy right here in a box. I'm not going to put negative 3. I'm going to put 3. It's always x minus a number. So if it was x minus 1, I put 1. If it was x minus 7, I put 7. Okay? If it's x plus a number, well, that's really like x minus negative of that number. So for example, it's x plus 3, I put negative 3 in this box. If it was x plus 7, I put negative 7 in this box. So that does take some remembering, and you're going to have to go through that process of remembering that. Now I put a line right here to separate what's happening, and what I do is this. First thing I do is I drop this 2 down. There it is. I drop the 2 down. And then what I do is I multiply 3 times 2, and I get that number. So 3 times 2 equals 6. So I put the 6 right there. Okay? And then what I do is I add down. If I add down here, I'm going to get negative 1. Okay? And then I go through a very similar process. I go 3 times negative 1. And that gave me negative 3. So I put a negative 3 here. And I add down and I get negative 3. And then I go 3 times negative 3. And that gives me negative 9. And I add 5 and negative 9. And that gives me a remainder, negative 4. So the solution to this is given right here. And so what I get is I get here, this is my remainder term. I get my constant term. I get my x term. And I get my x squared term. Always start with the remainder term. This is my remainder, my constant term, my x term, my x squared term. If we keep going, the x cubed, x to the 4th, and so forth. So I've got my answer here. Okay? So the answer to this is 2x squared minus x minus 3 plus, what's my remainder? Negative 4 divided by x minus 3. Okay? And it's that simple, guys, to go through this process. Okay? Again, what do? I take the coefficients of each of these terms. Good. I drop the first one down, multiply, put it here, add down, multiply, put it here, add down, multiply, put it here, add down. Remainder term, constant term, x squared term. Done. There it is. Okay, let's try a little bit more difficult one. Okay? So on this one, let's go through the numbers, the coefficients of each number. So I have x to the 5th, good. The next one is x to the 4th. I don't have one up here, so I put 0. I've got 3x to the 3rd, so I'm going to put a 3. I've got no x squareds. I've got no x's, but then I got a negative 6 constant term. Draw my line. The number I'm going to put in the box is not going to be 1 because I always want x minus a number. And you'll note that x plus 1 is the same thing as x minus negative 1. So negative 1 is the number I put in the box. Okay, drop it down. Drop down my 1. Multiply here. That gives me negative 1. Add down, negative 1. Okay, multiply, negative 1 times negative 1 is 1. Add down gives me, 4. Multiply gives me negative 4. Add down, negative 4. Multiply gives me positive 4. Oops, wrong color. Add down, 4. Multiply, negative 4. Oh, wrong color again. Add down, negative 10. Good. Okay. What do we start with? We always start with the remainder. This is my remainder term. Okay? This is my constant. X squared, x to the third, x to the fourth. Right? So what's my answer? The answer to this thing is, erase this real quick. It's going to be x to the fourth minus 1x to the third plus 4x squared minus 4x plus 4 minus 10 divided by my divisor, x plus 1. Okay? And there it is. Okay, so I've got this remainder theorem here. Okay, and this is going to be super important for us. It says if the polynomial p of x is divided by x minus c, then the remainder is p of c. What the heck does that mean? Well, I want to kind of show it to you by doing a long way with this one and then a short way. So my question is, what is the remainder when I have this polynomial divided by x plus 2? Well, one way to do that is to use synthetic division, just like we just practiced. So I'll have 3, 5, negative 4, 0, because there's no x squared, placeholder 7 and 3, and draw a line. What number goes in the box? It's not going to be 2. It's going to be negative 2. Now I can only do this because this is a linear factor of the form x minus c. Okay? Can't do it if it was a number in front of this. Okay? Only when it's a linear factor of the form x minus c. Good. Got this guy? Go through this process. Drop down 3. Good. Multiply gives me negative 6. Add down gives me negative 1. Multiply gives me 2. Add down negative 2. Positive 4. Add down that gives me 4. Negative 8. Add down gives me negative 1. Multiply gives me 2, and I get 5. So 5 is my remainder when I go through this synthetic division process. But this is one way to do it. This is, say, one way to do it. Check out another way to do it. According to this theorem, if I have a factor of x minus c, and I want to just look at the remainder, this again is x minus negative 2. Well, I can find the remainder just by plugging in that value c into my polynomial. That is, what is p of negative 2? Again, x minus c, x minus negative 2, so negative 2. What happens when I plug in negative 2 into that polynomial? Well, I get 3 times negative 2 to the 5th plus 5 times negative 2 to the 4th minus 4 times negative 2 to the 3rd plus 7 times negative 2 plus 3, right? So I get 32 times negative 32 times 3 is negative 96. Positive 16 times 5 is 80. Negative 8 times negative 4 is positive 32. Minus 14 plus 3. Okay, I'm just doing some arithmetic here. Here it gives me negative 16. Negative 16 plus 32 is positive 16. 16 take away 14 is 2. 2 plus 3 is 5. And it turns out to be the same number. Now this is interesting because this is a theorem. It's always true. Whenever I have a polynomial and divide it by something in the form x minus a number, I'm always going to get the remainder to be, just by simply, if I would have plugged in that value, x minus what number? Negative 2. If I just plugged in the polynomial, that'll give me the same remainder as if I did some long division process. Okay, so I've got the remainder theorem written up here again. Again, the polynomial p of x is divided by x minus c, then the remainder is p of c. Now, something that follows from this is the factor theorem, which says c is a 0 of p if and only if x minus c is a factor of p of x. Okay? So, what that tells us, guys, is that a 0, again, is an x-intercept. But a 0 means x minus c is a factor of it. And what we can do is we can use the remainder theorem along with the factor theorem to factor things that we probably haven't been able to factor before. For example, suppose I have this. Suppose p of x equals, let's say, x cubed, what do I have here? X cubed minus 7x plus 6. Okay? Suppose I have x cubed minus 7x plus 6. Now, suppose I want to factor that thing completely. Well, one thing I want to note that, suppose I also know that p of 1 equals, what happens to p of 1? Well, what does p of 1 equal? Well, if I put in 1 in here, we know that 1 cubed is 1, minus 7 times 1 plus 6, which says this equals 0, doesn't it? So p of 1 equals 0, which means there's 0 remainder when I plugged in 1 into this polynomial. If there's 0 remainder, well, doesn't that mean that it goes in perfectly if you're dividing something? Like, if I have 35 divided by 7, right? The answer is 5, and there's 0 remainder because 7 went in perfectly. Well, because there's 0 remainder, this gave us the fact that I have 0 remainder, then we can conclude that x minus, what number is that? That's 1, is a factor of p of x. If my remainder is 0, if c is a 0, that is, it makes it give you 0, then x minus 1 is a factor, right? 1 was a 0, 1 gave me 0. X minus 1 is a factor. X minus 1 is a factor of it. So what? So what if x minus 1 is a factor? Well, that means this thing can be written as x minus 1 times stuff. X minus 1 times stuff. Now, you can't do like some other process to factor this. You can't use tic-tac-toe or the AC method or some other method because this is not a quadratic, right? We don't know how to factor this using the techniques of algebra. However, we do know that it can be factored in x minus 1 out of this. That is to say, x minus 1 times something equals this. Well, how do I find out this something? You divide it out. You can use long division, right? So if I have here long division, or in this case synthetic division might be easier, I'd put 1 in a box. I'd go 1, 0, negative 7, 6. Draw my line. 1, 0, negative 7, 6. Put down a 1. 1 times 1 is 1. Add down 1. 1 times 1 is 1. Add down negative 6. 1 times negative 6 is negative 6. Remainder better be 0. Otherwise you did your math wrong over here. And that says that this is my constant term. Then this is my constant term. This is my remainder. My constant term is my x term. This is my x squared term. So here I'll have x squared plus x minus 6. Okay? X squared plus x minus 6. Now, this is a quadratic, and you could factor this thing using techniques of factoring, and you'll get this to equal x minus 1 times x plus 3 times x minus 2. Again, I just factored this thing to get to that. So this factor theorem allowed me to, noting that p of 1 equals 0, I can extract that factor x minus 1 and then use synthetic division or long division to do the rest of it. Okay? So this is a tremendous theorem that allows us to factor things that we normally did not have techniques to be able to factor.